Hello everyone, I have a small bar magnet out here in the picture and I want to move this magnet without touching. So to do that I can bring another big bar magnet and I can rotate this magnet using the magnetic field of this magnet. Similarly, a magnetic compass is a small bar magnet. So if you want to move this, you can bring a magnet. So in the magnetic field of this big magnet, the small bar magnet moves. So let's talk about this Oersted experiment. So he took one conductor and near to that conductor he kept one magnetic compass and he connected the conductor with the circuit, and when he switched on the circuit he found that there is a deflection in a magnetic compass, and when he switched off the current there was no deflection, and when he changed the direction of current the direction of deflection also changed. So as we have already seen that in order to move this magnetic compass we need magnetic field, so we are generating magnetic field somewhere in the circuit. So he gave the conclusion: current carrying conductor produces magnetic field, and from his conclusion we got a chapter on moving charges and magnetism. So as we have said that a current carrying conductor produces magnetic field, the question comes how much magnetic field and the magnetic field in which direction. So answer to these two questions was given by Biot-Savart law will give the idea of how much magnetic field is produced, and the direction is given by right hand thumb rule. So let's see Biot-Savart law. Suppose I have a conductor in which current I is flowing and I'm taking a small length dl, I call it current element, and I'm taking a point P. So I want to find the magnetic field due to this length dl at point P. So the distance of point P is r, and this is the r vector towards the point P, and this dl is the direction of this element length. So it is just the tangent to the wire. So let theta be the angle between dl and r. So I want to find the magnetic field out here. So Biot-Savart law says that the magnetic field at this point P is directly proportional to the current flowing through the conductor, directly proportional to the length of the conductor, and proportional to the sine of angle between dl and r, and inversely proportional to the square of the distance of point P from the conductor. So if you combine them all you will get dB, small magnetic field, is proportional to I dl, small length, sine theta, the angle between r and dl, and the square of the distance of point P from the conductor. So if you want to convert this proportionality sign into is equal to, then you have to multiply with a constant, and this mu naught by 4 pi is the proportionality constant, and unit of this magnetic field is Tesla, and the value of this proportionality constant is 10 to the power minus 7 Tesla meter per ampere. So from here you can write, see this, the unit of magnetic field is Tesla, and from here you will get meter square, and from here you will get ampere meter. So meter and meter square will cancel, so you are left with Tesla meter per ampere. So you can try by yourself. And this mu naught is called permeability, not permittivity, it's permeability. So for magnetism it's permeability of free space, and its value is 4 pi into 10 to the power minus 7 Tesla meter per ampere. If you want to write this Biot-Savart law in vector form, then you can multiply and divide this expression by r, and out here you'll get r dl sine theta by r cube. So r dl sine theta, r and dl is a vector, so if you have sine theta, you can write it as a cross product. So in vector form you can write dB is equal to mu naught by 4 pi I dl cross r by r cube. So this is in vector form. Now let's see the special cases. So when the angle is 0, meaning this angle is 0, so the point lie on the conductor itself, so that time the magnetic field will be 0 because sine theta is 0. So if you put the theta is equal to 0 in the Biot-Savart law, you will get B is equal to 0. So that means there will be no magnetic field inside the conductor. And if you take this angle to be 90 degree, then that time this sine theta become 1 and magnetic field become maximum. So at this point the magnetic field due to this part of a conductor is maximum out here.